Hi, my name is Zach, and welcome to our Transport Tote Lift project. In this video, we will be going over key aspects of our design and its intended purpose. Lifetime Assistance is a company that offers a full spectrum of residential, vocational, and support services throughout the greater Rochester area and beyond to empower individuals with intellectual and developmental disabilities. The goal of this project was to design and construct a device for the paper scanning and shredding division of Lifetime Assistance that allows employees to independently lift and move heavy totes full of paper. The current process of moving totes requires 2 to 3 employees to lift a tote on top of a push cart. The cart is then wheeled to the desired location, and the employees then have to lift the tote onto the tabletop. The final product created by the team reduces the number of workers required to move a tote from multiple to just one single employee. The device works by approaching a tote and sliding the forks on either side. The tote can then be lifted up and transported to the required location, where it is then deposited on top of the table. The lifting of the totes is achieved using a screw jack. 2 ball screws are positioned on the front of the device, driven by a single motor in the base of the device. A chain and sprocket assembly is used to deliver equal torque to each screw. A welded fork assembly is slid over the screw on a pair of ball nuts that allow the forks to translate vertically. Additionally, linear guide rails are fastened onto the side of the frame, ensuring the screws do not bend from the weight of the totes. The frame is constructed of 1018 carbon steel, which is welded at the intersection points. The steel provides adequate strength while also being cost effective. The intersections of the device are protected using a combination of sheet metal and acrylic, attached to the frame with fasteners. Acrylic is utilized in the upper section of the device, allowing for operators to see through and improving their visibility. Sheet metal was used to cover the sides, which helps protect the internal components. The device is driven using 2 rear wheels, which are both independently driven with their own motors. 2 anti-tipping legs are welded to the front with ball transfers to help balance the device with the weight of the totes. The device is controlled using a combination of handle controls and a panel. The handles were designed with feedback from the client throughout the process. The final handle design utilizes 2 vertical bars to grip with buttons in the end that control the 2 drive motors. The control panel houses controls for lifting and lowering the prongs in the form of 2 triangle buttons, a rocker switch that changes the drive motors between forwards and reverse, and an emergency stop button to cut power to the device if needed. The whole system is provided power by 2 12-volt batteries wired in series. A custom charging port was created to allow the device to be plugged into the wall for easy charging. The batteries are wired directly into an Arduino, which serves as the brain of the device. The Arduino then wires into all the control buttons, a backup alarm, and 3 separate motor drivers that control the speeds of both the drive system and the screw system. The Tote Transport Lift serves to increase the independence of the employees of Lifetime Assistance in their day-to-day operations. We would like to give a big thanks to the New York State Industries for the Disabled, Lifetime Assistance, and RIT Multidisciplinary Studies for making this project possible. We would also like to thank our project guide, Professor Gerald Fly, along with Dominic Basile and Rick Werzer in the machine shop for guidance throughout the project. Finally, we would also like to give an additional thanks to all of our partners seen on screen for aiding us in completion of our project. Thank you. Thank you for watching our video. We hope you enjoyed.